Today we have Moe, like I said, joining us all the way from Dallas, Texas. Moe holds an Associate of Applied Science degree in dental technology from Southern Illinois University since 1990. He has 28 years of bench experience, 15 of which had his own lab. He has worked with 3Shape dental wings and is currently very proficient in exocad with a total of 15 years of digital and CAD CAM working with systems. Before Elos, he was with Aman Gearbuck, and he holds a global certified instructor with them. So we're really great. Mo's our go-to guy for Elos, and we really welcome him joining us, and it's wonderful. Thanks, Mo, for being here.
Thank you for having me. It's always a pleasure to be here, and I always have fun working with you guys. So like Mark said, we're going to be talking about scan bodies today, and hopefully in the future we keep introducing new components with new webinars for the Canadian region as time progresses. So for today, let's get this webinar started, and we can answer questions after the fact. Due to the time limitation, please, if you have any questions, write them down in the Q&A section. And after the webinar, we'll certainly make time to answer all the questions. All right. I would like to thank everybody for attending one more time, and also allow me to introduce just a handful of slides, like maybe 3 or 4, on the history of the company, because with these webinars, we always have newcomers, and I would like to keep everybody informed on the same level and have everybody on the same page with how our products got developed and where we come from and all that. So certainly not trying to be redundant, just keeping everybody informed more or less. And Elos is a worldwide company. We have 4 business units, 13 production sites worldwide. Certain production sites are specific to certain regions, depending on what it is that they are producing. Keep in mind that dental only makes 25% of Elos MedTech. The rest of it is other things. And for the implant prosthetics, for the dental side, everything is 100% manufactured in Denmark. Throughout this timeline, the company was founded in 1923, deep in the heart of Sweden. From 1923 till the mid-50s, all we did is design and manufacture and also repair wood cutting tools that were used to build wooden houses. In the mid-50s, we got into the medical field, and then our first footprint in the dental industry was not until 75, and that was due to the collaboration with Professor Brannemark. So Professor Brannemark reached out to Elos in the mid-70s to help him design and manufacture the first titanium components that he used to test in rabbits for the implementology project that he had. We also all know that Professor Brannemark went on to develop a company called Nobel Pharma, which essentially became Nobel Biocare. So therefore, we are by default almost been with Nobel Biocare since day one. However, our really true big footprint in the dental world did not come till 2010. That was also due to the collaboration between us and 3Shape. In 2008, 3Shape reached out to us to help them develop and design and manufacture, which ended up becoming the very first scan body in the market. So in 2010, we launched the very first scan body due to the collaboration with 3Shape. And then 2 years later, we enhanced and evolved that scan body to have the IO line, which was launched in 2012. And that particular line been very successful for us. We ran with it for about 12 years until 2024, when we found or realized we have a need to have something different and something better. Now, ever since we launched the very first scan body, we also started to introduce different components in the industry, from analogs to screws to hybrid bases to pre-milled blanks and whatnot. And we always have stuff in the pipeline. So hopefully by next year, we're going to be launching some new components that would be significant for the industry as well. So for now, our focus is just going to be on scan bodies in general, whether it is the IO or the main ScanBody22, of course. Now, throughout the years, we have built and established a long-standing legacy. Our legacy started with the long-standing history in implementology, and that was due to the collaboration between us and Professor Brennemark in the mid-70s, and also due to the collaboration we've had with Reshape when we established the very first scan body, just like I said. And then also we have been contract manufacturing implant components for the major implant companies since 1992. So obviously, many of the OEM components that you actually buy from original implant companies, a lot of them are made by us. So we have established a cleared focus on quality and precision throughout the years because of that collaboration with implant companies. And a lot of them trust our quality and our precision to actually make a lot of their original components. And they get sold under their name with their brand on it and all that. But in the background, in the back scene, we actually make a lot of these components. And finally, we are also known to have a predictable solution, and that was due to our persistent, consistent, accurate, reliable results that we've had over the years. So for all of you guys who have used Elos before or know about Elos, it is known to have a predictable outcome every time, and the precision and the accuracy that we have is unmatched. In our manufacturing process, we have extremely tight tolerances that will exceed any of the competitors' tolerances in the manufacturing aspect. Now, due to our collaboration with implant manufacturers since '92, they have actually trusted what we have, they trusted what we make, and they trusted us enough, and they understand what accuracy and precision that we have, to a point that they actually embedded our scan body data into their own libraries, just throughout the years. And we all know anytime you're talking about a dental digital workflow, everything has to start with a scan body. So that's a very important element. That's the starting or the beginning of the entire process. If your initial start is not based on something solid, something accurate, then everything you do moving forward is not going to be accurate. And inaccuracies keep building up because there are tolerances in every step that you do. And there are some discrepancies that keep increasing in every step. So if your starting point is off, your end point is going to be way off. Now, looking at this chart here, if we look at Straumann actually has embedded our our scan body data into their original library side by side. So if you're working with a Straumann workflow, Straumann components, once you get to the scan body selection, you will actually find our scan body data right next to the original Straumann scan body into their own library. And because Medentika is owned by Straumann, you will also find the same thing with the Medentika library as Straumann. Then Nobel Biocare has our scan bodies, analogs, and hybrid bases. Bego has our analogs and screws. Plan Mecca is a business partner. They actually resell some of our components, and in their original workflow, they also have our scan bodies, analogs, and pre-milled blanks. GC has our scan bodies and analogs. Neos has scan bodies and analogs. Dentsply Sirona is also a big customer. They also have our scan bodies, analogs, and hybrid bases, just like just like Nobel does. And because Atlantis is also owned by Dentsply Sirona, you'll find the exact same components into the Atlantis library as they are in the Dentsply Sirona library. BioHorizon, you'll find our scan bodies and hybrid bases. And finally, IMS iCore also is a business partner. They resell some of our components. And just like Plan Mecca, in their own workflow, you will find our hybrid bases, pre-milled blanks, and analogs. Now, before we jump into the conversation of ScanBody22, allow me to shed a little light on the original IO line, or the PEEK scan body. So our PEEK scan body that we've had great success with over the years consisted of a titanium sleeve. Then we took the screw, inserted it from the top, and then snapped the PEEK on top of the titanium sleeve. Now, the couple of downfalls that the PEEK scan body had, which were the cause of us seeing a need that we need something better, is the first one: if the end user end up misusing or overusing the PEEK scan body, sometimes in some cases the PEEK would start to deglove or separate from the titanium. And the minute that happens, if it goes undetected by the end user, then inaccuracies start to take place. The second downfall with the PEEK line was that it is not X-ray visible. Obviously, the titanium part is, but the PEEK was certainly not X-ray visible. Now, please remember, all scan bodies, whether they're the IO line or whether they're the ScanBody22 or the titanium, they need to be hand torqued only. No wrenches, no torque wrenches, no tools of any kind, just by hand, and they don't need to go over 5 Newton centimeters, which is easily achievable by hand torque. Now, one of the common comments that I hear from the end users on our scan bodies in general is the fact that people sometimes get annoyed that they have to have our own driver for a scan body, for our scan bodies. Now, the reason behind that is, in order for us to achieve the quality and consistency that we needed, we had to make the hole super small to increase the scannable surface. So basically, the smaller the hole, the larger the scannable surface. The larger the scannable surface, the more accurate the end result will be. And that's why end users have to have our drivers for the scan bodies. Now, the bright side about this, even though we have several drivers that are all the same, you got to have just one of the drivers, and that will fit pretty much all the scan bodies. The hex on them is all the same. It's just different handles for different purposes. Now, before we jump into ScanBody22, let me also highlight one of the most asked questions that I get on regular basis. And this is on the Nobel conical connection. And it has been very confusing for a lot of clinicians and a lot of lab techs. With the conical connection, we all know that the Nobel conical connection active has a two-solution platform. The first one is conical, which basically, is engaging, and the second one is sits flat to flat surface or connection. So the conical connection, the one that is engaging, that sits inside the cone, is intended for single units. The flat to flat is intended for multiple units or bridges. And a lot of times customers did not know which is which, either on the clinical side or sometimes on the lab side. Sometimes the doctor would scan the correct scan body, but in the lab workflow, the lab technician would align the scan body to the wrong data or in the library. And that would either way, you'd end up with the same results. The occlusion is going to be off by about millimeter, either 1 millimeter too high or 1 millimeter too short. So it is important that you understand the difference between the two, and it is important that the correct scan body is used on the correct case. Now, also the same thing goes for the healing caps. On the conical connection, there are also two healing caps. One is engaging, one is non-engaging. Same purpose. Now, if the wrong healing cap is used, it causes a slightly different issue. But at the end of the day, the result will be that the scan body is not seating properly. Now, our focus is not going to be on healing caps, but if we have any doctors in the house, it is also important to know that the correct healing cap must be used. Now, if we look a little deeper on the coding and the confusion that was or is taking place with the conical connection on the peak line, is the engaging one that is intended for single units always had SA, single abutment, at the end of the code. So for example, you're going to see IO2B-B SA. That certainly is for single units. The one that does not have SA is intended for bridges or multiple units, and that was the flat-to-flat system, or flat-to-flat solution, I should say. And you could clearly see the difference here. This is the engaging, and this is the non-engaging, or the flat-to-flat. The peak basically touches the top of the implant, and it sits flat on the top of the implant. Now, we also said that the peak scan body is not X-ray visible, and that was one of the challenges that we've had, and that was one of the reasons why we needed to improve on that and have something different. So the titanium sleeve can be visible, obviously, but then the peak part is not seen in the X-ray, and the clinician does not know whether it's really seating properly a lot of the times. So we needed to have something that is X-ray visible to ensure or assure the clinician that the scan body is sitting the way it's supposed to be precisely. Now, ScanBody22 is what we have. ScanBody22 was launched in 2024, and the number 22 in the name came from the atomic number being the titanium atomic number on the chart. So 22 is the atomic number for titanium, and that's why we call it ScanBody22, because it is a titanium scan body. Now, the benefits on ScanBody22 are or has the exact same benefits as the peak plus more. So obviously the elephant in the room is the X-ray visibility. So this being a titanium scan body, it is certainly X-ray visible. Now, what gives ScanBody22 the ability to be as scannable as the peak, if not better, is what we call the aquascan surface. The aquascan surface is a surface that is grown chemically from the titanium within. It is grown precisely at 3 microns, and this surface is what gives it the gray dull look, and this surface is what gives it the ability to be as scannable as the peak, if not better. The aquascan surface gives it also the durability that it has. Now, the window on ScanBody22 is an addition that the peak ScanBody did not have. The window on ScanBody22 serves three purposes. Purpose number one is a safety feature, meaning if the clinician is worried that the scan body may slip and slide down the patient's throat, they can always thread a line or a floss through the window and secure that the scan body is not going to go down the patient's throat in case it slips out of their finger or ends up falling out. The second purpose the window serves is for the cleansability aspect. It allows liquids or steams to go to the internal components of the scan body, which allows a better decontamination or disinfection of the scan body. The third purpose the window serves is to allow us to insert the screw from the bottom, because obviously this is a one-piece scan body. It is not a multiple components that are put together, and there is no chance of anything becoming loose or degloving or separating. Because it is one piece, the only way to insert the screw is to slide the screw shaft from the bottom and then utilize the window to slide the screw head through the window and then attach the screw head to the shaft with a C-clamp. Once they are clamped together, then they become one piece and it's not going anywhere. Then we also changed the naming structure to where it makes a lot more sense and it's easier to read and get identified by the end user on what brand or platform that is. And also one of the biggest advantages that ScanBody22 has over the Peak is we also changed the gingival area on it to a much slimmer design, especially useful for those implants that are deep subgingivally. So the gingival area on the scan body is a lot slimmer than the Peak was, and it allows the end user to utilize it at a much more ease with the implants that are sitting deeply under the tissue. ScanBody22 is certainly usable for up to 100 cycles, just like the Peak scan body. And then finally, it is backward compatible, meaning if you scan ScanBody22, you can align it with the old Peak line. Now, please remember the only line that, excuse me, the only line that this is not possible with is the Nobel CC in particular. All the other brands, all the other platforms are backward compatible except the Nobel CC, and that was by design to also help solve the issue that we've had with the confusion between the two solutions the conical connection has. And I'll explain that in more details in the next couple of slides. So in this slide here, you will certainly see that ScanBody22 is certainly X-ray visible. It can't be any more X-ray visible than this. The clinician will have no doubt whether it's seating properly or not. And it's certainly because of the AquaScan surface. It has a non-oxidizing surface that is autoclavable at 100 cycles, just like I said, and it is scratch-resistant layer. And due to the kind of surface it is, the way it is made, it is certainly non-reflective, optimized scanning to optimize the scanning ability for the ScanBody22, which we've already discussed. Now, once we started to compare ScanBody22 to the other titanium scan bodies in the market, we realized that almost every titanium scan body will have some sort of a scatter on the outer edge, or artifacts is what we call them, and that is due to some sort of reflection. Now, if you look here, ScanBody22 has almost no scatter, none whatsoever. It is as clean and as smooth as possible, and that means the reflection was almost non-existing. And these artifacts here, once you align the scan body to the library data, then they will play a role, and then it will create some sort of a certain level of inaccuracy. And this here indicates that ScanBody22 is going to be a lot more accurate than the competitors in the alignment process. If we look at the triangulation result, you're going to see the same thing. This waviness on the data is an indication that there are some uneven alignment or uneven scan due to the artifacts, where ScanBody22 is as clean, as smooth as possible. Once you align things and we start to zoom in closely to see if there is any discrepancy between the scan and the library data, almost with every competitors, there has been a certain level of increased tolerance in the discrepancy between the two datas, especially around the corners. That's where most of the discrepancy took place. So every single one averaged anywhere from, I would say, maybe 18 to 15 microns all the way up to 25, 30 microns. And that's significant. Where ScanBody22, the data was almost spot on. We zoomed in as closely as we can, and we could not detect anything bigger than 3 microns. That's very significant. That's going to give you a result that you're going to start with an extremely high accuracy right from the get-go. Now, again, here this shows that the ScanBody22 geometry is certainly backward compatible with the peak. Like I said earlier, you can take ScanBody22 data and line it up with the peak library without a problem, except for the Nobel CC, and that was by design. To eliminate the confusion that we talked about prior, we just simply laser printed on the single one, on the engaging one, the word single, and on the non-engaging one, the word bridge. This basically is as obvious as can be. Now, if the end user misses the laser printed part, we also ensured that we change the geometry on the top of the scan body. So for the non-engaging, we made it completely flat. For the engaging, we changed the geometry of the slope, and then we added a second slope. So this change right here that you see on the top of the scan body ensures that the end user is not going to align this with the peak library accidentally. So for the conical connection specifically, if you're trying to use ScanBody22 on that line, you must download the new library. For everything else, you can utilize the old library, no problem. Now, on the drivers, we also enhanced the ScanBody drivers to some extent. The new driver is made from a much more durable material. It also has the shape of a ScanBody, so it is easily identified. If it's sitting on the bench, you're not going to be searching for it for too long, because just with a glance you can see that it is the ScanBody driver because the handle looks like a ScanBody. It does also have the hole just like the ScanBody itself to help secure it and ease any worry that the clinician may have that the driver might slip out of their finger and falls down the patient's throat. They can secure it with a thread, as you can see in this picture, and the same goes for the ScanBody. Now, these are the three most common drivers that we have. Obviously, the SBD-M-1 is the most common, most sold driver. The one in the middle right here is the shortest one. We call this the stubby, and this is useful in patients that can't open like really wide, and maybe the clinician is working on the back molars. It can come in handy because it's slightly a little bit shorter than the SBD. Now, the one you see on the very far left is intended for labs. This is too long to go in any patient's mouth, but I've also seen labs utilize also the other two. So anyway, I mean, all three can be utilized by lab tech. For clinicians, it's basically just the one on the far right and the one in the middle. Please remember, all drivers have the exact same hex, just a different handle, different height, but all serve the exact same thing. All you need is one driver for all the scan bodies. And also, please remember that they also need to be just hand torqued, no more than 5 Newton centimeters. I cannot emphasize on this statement enough. I still see people wanting to take a plier or take a torque wrench and go at it on a scan body. And if you do that, you're going to strip the screw in a hurry. Now, I have a short video here to show you. It's a testimonial video that was done by our KOL in the UK, Steve Campbell. He's a very renowned technician. He owns Nexus Dental Lab, and he sits on the bench daily. He's a very dynamic speaker. If you've never seen him, if you happen to catch him here or there, he's a lot of fun to watch.
Hi, my name's Steve Campbell. I'm the Managing Director of Nexus Dental Laboratory. We're at our Ripon studio today, which is our CAD Central hub, and we're going to look at our partnership with Elos MedTech and why we're using their ScanBody22. The reason for us that it became an essential is because we started a completely digital dental laboratory 7 years ago. The reason we started a digital lab is we needed to be efficient and effective, and the old way of working wasn't. There was a need for us to change the way things are being done. It's a complete paradigm shift from the old art, craft way of working. It was very laborious and time consuming. And that digital workflow means that we get consistency, efficiency, and we also maximize the workflow from our team. So with Elos MedTech, we now have ScanBody22. ScanBody22 is an evolution of everything we've come to rely on. So we already have the accuracy, the stability, but what they've done is they've made it so that it's easier to trace in X-ray, which is critical because most of the implants we're seeing, the trend is towards deep subcrestal. So there's a risk of bone binding and bone engagement. We can now see that, and the surgery can clearly see that it's clear. It also has a special coating, which means that when we align it, there's less scatter. It's super, super tight, which means that when we work in micron factors, there's less risk of adjustment coming forward. And also from the surgery point of view, it's a nice one piece, easy to decontaminate, easy to reuse and bring back. So what we're getting with ScanBody22 is all the benefits we had before, but now this evolution enhancement in accuracy, in usability, and the new X-ray traceability. I think it's going to be an incredible scan body. So we took the decision to actually start supplying scan flows to our clients, saying, do you know what, we know this is the best, we know it's the best for you too, we're going to supply them for you. And it's just allowed us to really unleash amazing growth and potential now. And what we're now seeing is a scan body that has a new coating, a unique coating, that when we look at these scans and the scan scatter, it's super clean. Now the cleaner it is, the more accurate our library marry is going to be. And everything comes down to these accuracy levels. They're a one-piece scan body that we're looking at now, rather than two pieces, because in the past we have seen the competitor ones deglove, essentially, where they're pulled apart. The crucial bit is, we all throw the term implants and teeth around, but we're making medical devices, and there's a patient at the end of every journey. That patient is going to have that to restore their form, function, aesthetics. So it's got to be right, and we've got the best partnerships to help us deliver on that, I think. It's not an exaggeration to say our collaboration with Elos MedTech is the reason we have the success with Nexus. Your reputation is everything in this industry. You have to deliver. We have a very low incident rate because we trust the workflow. We know the accuracy and consistency is there, which means that when our surgeon goes to fit it, the patient leaves happy. That's the goal of the whole team. It's the reason we're here. It's the reason we're growing so fast. It's because of that partnership. And if you choose the right partner, there is no limitation to where you can go. Elos MedTech is our trusted partner.
Like I said, Steve is always dynamic and a lot of fun to watch. So anyway, back to our conversation. We have one PDF or one-page PDF on our website that you guys can download. If you need help finding it, let me know. I'll guide you to it, or I can email it to you. It just basically shows you the best practices, the best guidelines for the proper sterilization of the scan body and the torque wrench if need to. Now, when we talk about libraries, we have obviously compatibility with exocad and 3Shape. We've always had those. Now, there are two sets of libraries for each one of the two softwares. You're going to find one that says FDA, the other one that's going to say rest of the world. For you guys in Canada, you can download the rest of the world library for either one of the two softwares. And that's going to actually give you a little bit more components than what we have approved in the US. So the FDA is intended for US users. Rest of the world is intended for everybody else. Finally, our warranty is important to talk about. This is something we've had in writing. I can provide it for anybody who wants it in writing, no problem. It's a warranty we've had for many years, and luckily we've never had to use it once because we are very confident with the components that we have. So basically the written warranty consists of, if you use the Elos components and something ends up going south and later on, whether it's 6 months later, a year later, 2 years later, doesn't matter. If something goes south and it was determined to be that the cause is because of the Elos components, not only that we will replace or reimburse you for the Elos components, but we will also pay fully to replace the implants from A to Z, including parts, labor, and everything else in between. This is a written guarantee that I can provide again to anybody who wants it in writing. And finally, as far as regulatory and compliance, obviously Elos MedTech is not only known for the accuracy and precision, but we are also known to be in compliance in every market or every region that we do business in. This is something we're very keen on, whether it's Health Canada, DMR in Europe, or FDA in the US. We have an entire team that works tirelessly to ensure that all our compliance and regulations are met in every region, and they're very, very thorough. As a matter of fact, if you look here, this is an interesting statement. For just the prosthetic screw alone, we have 1,500 documents, 1,500 pages on something as simple as a screw. Imagine how many pages we would have on something a little bit more complex like a hybrid base or a pre-milled blank or something like that. So again, we have an entire team that works tirelessly to ensure that we are constantly in compliance in every region and every market that we do business in. And thank you so much for listening. Thank you for attending. And we will open up for questions at this time. So if you have any questions, I'll be more than happy to answer any of them. If I don't get a chance to answer somebody right now because of time, I will certainly get back with you with an email. So I'll email you, or you can email me any questions that you may have at a later time. Thank you again, and until next webinar, you guys take care. We'll take questions right now.
Much, Mo. Always great for the webinars that you do to see the background and the logic and preparation that goes into it. And I'm really happy that you talked about the library matching and the detail that we're able to get with the scanners now. So thank you very much for that. If it's okay with you, I'm just going to check the Q&A and see if we have a few questions here for you.
Sure, absolutely.
Okay, we've got a few here. The first one is, can we use the old driver with a ScanBody22?
Yeah, that's a great question. Yes, absolutely you can. The driver is also backward compatible, just like the ScanBody is. You can use the old drivers on the new ScanBodies or the new driver on the old ScanBodies. The screw hex on the screw head is exactly the same. We did not change that. We just improved the ScanBody itself. The screw remained the same, therefore the driver remained the same.
Oh, excellent. And another question here. What is the reason that the ScanBody22 is only reusable 100 times?
Yes, so obviously nothing is made forever. Everything will essentially come to a point where you're going to start to have wear and tear on it, including these scan bodies. So throughout the testings that we have done over the years, we've noticed a scan body typically will withstand a lot of wear and tear throughout the process, unless, of course, an end user misuses it or abuse it a little too much, which we've had, occasionally from time to time, one of those. But typically, a scan body will withstand its accuracy and its integrity for up to 100 cycles without an issue. And then after the 100 cycles, you're going to start to see signs of wear and tear on it. And that's an indication that it is time to replace it and get a new one.
Excellent. Excellent. Thank you. Looks like I have one more here. I noticed on the scan body that there is a slope. What is the reason for this?
So the slope,
I guess it's referring to the alignment slope.
Right. So that's exactly what it would help with. It's for the indexing, and it is for the alignment. And the scannability aspect. So a lot of times when you're scanning, certain scanners look for variations in the geometry of anything, and it helps in the stitching part with the alignment. Also for the indexing part of the timing on the scan body, that's what it helps.
Does the orientation of the slope matter when scanning? I'm assuming they're talking about the plane or incline there.
So the orientation doesn't really matter. It's there for indexing purposes. A lot of doctors feel they can scan easier if it's facing the buccal, but whether it's facing the buccal or the lingual, it's not going to change your ability to design the case properly.
Excellent. Next question is, do you have any suggested sequence when scanning an implant restoration using ScanBody22?
So really what dictates the sequence is more of the intraoral scanner that is being used. From one scanner to another, the sequence may vary. However, all of them should allow you to scan, the obvious upper, lower, and bite. And then you want to scan something with a scan body. Where it can be more challenging, not so much with the sequence, but rather with something I see often. And as a designer who sat on the bench for a long time, quite a few years actually, and designed implants, it's always best if you have or able to get a scan of the socket without the scan body in place. I see this very often. A lot of times when clinicians scan, either because maybe their scanner doesn't allow it, or sometimes because they're just simply are not aware, or sometimes, they're just somebody's in a hurry. It's always best if you can give whomever is going to design the case a scan, even if you have to do a separate scan for that. If your scanner doesn't allow it, please take the time to take a separate scan of the socket without the scan body in place. And let me tell you why. From experience, when we get a scan with a scan body in place, most of the time, regardless of that scan body, the shape, the geometry of it, what brand, what company you got it from, it's eating up a good portion of that socket. The area that becomes invisible because of the scan body being there is the crucial area that we're trying to impinge on in our design with the emergence profile. And in many softwares, you can actually delete that scan body and have that space open when you're designing. But when you delete the scan body, almost every time, regardless of which software you're using, a portion of that socket, the inside part of the socket, disappears with it. And now when you're designing your emergence profile, a lot of times you're just kind of shooting in the dark. You're eyeballing it. And when you're eyeballing it, you could be over impinging on the tissue or under impinging on the tissue, or you're just really not being accurate. But if you can provide the designer, whomever that designer is, with a socket scan without the scan body in place, that's the most ideal. If you can't, you can't. It's obviously something we can work with or work around. But for the ultimate results, for the best results, it would be best if you can provide a scan without the scan body in place. Now, as far as the sequence, like I said, it really does not matter. From one scanner to another, it may vary slightly, but almost every scanner out there is going to allow you to do upper, lower, and bite, and then a scan of the scan body. Now, some will allow you to do a fifth scan, and that's going to be the scan with a scan body out, just for the socket. Some will not. If not, and you have the time, please take one, even if it's in a second case, but capture enough info from the arch to allow the designer to line the data in the design software. Because if you just capture that socket with nothing around it, then the designer is not going to have enough info to really make proper alignment, and then it's almost going to be useless. But that's just more of a tip, really.
No, it's an excellent
So,
point. In fact, we had a
sorry,
call from an office about it.
yeah, I took a little too long on that one, but I feel
No,
it's important because I've seen that a lot.
no, exactly. We actually had a call from an office last night that the patient had left the chair, and they realized after the fact there was a little bit of the contact missing from the scan, exactly what you're describing. So
Yes.
that was great to take that time. The next question I have here is I saw that the hybrid base G is launching in 2026. Do you have a timeline for Canada?
So the timeline, typically, the general rule, whatever we get in the US, Canada gets a few months after. Now, on this particular component, because there was an unnecessary delay on it, we're trying to launch it at the same time in the US and Canada. However, we're expecting it here to get into the US sometime in October, November. And they tell us September, but I always like to add another month or two for just a cushion, because things, with these type of regulations and approvals don't necessarily flow exactly like you kind of envisioned. But let's say, hypothetically speaking, between October and the end of the year, and hopefully we're going to get Canada at the same time. If not, it's just going to be like a couple months down the road. So if it's not by the end of this year, it's going to be very early next year for sure.
Excellent. Well, thank you very much, Mo. As I mentioned earlier, a wealth of knowledge. And for anyone out there, if we can't help you here with any challenges that can arise, then we always have Mo that's out there for us to help, at next level as well. So thank you again, Mo, for
Thank you.
taking the time today. The